Welcome back, everyone. In this module, we're going to take a look at iterators and what they are. Now, iterators and iterables are two different things. We have been dealing with iterables quite a bit. So if you have an iterable, you have something that can be looped over, a list, a tuple. There are examples of iterables. In fact, for that matter, if I have a string, for instance, we know we can loop over the characters. So they're all iterables. Now, what does it mean for something to be an iterator? It means that it has a state that it can remember, as we will see. But first, let's take a look at an example of an iterable, something that we've seen over and over. Here I have a list called nums, which has 3 digits in it, 1, 2, 3. We know we can loop over that. We just say for num in nums, and we get 1, 2, 3 be spit out here. How can we tell if something is iterable? Notice iterable, not an iterator. It has the iter method, the iter dunder method in it. So if I look at my nums list that I did and I do the dir nums, I should see this double underscore iter double underscore open close round brackets. And if you take a look, somewhere in here should be iter. There it is, right there. So we know that this list then must be an iterable object. So having this means there is that the object is iterable. Now, what's an iterator more precisely? It's an object with a state that knows where it is during an iteration. If you guys are old enough, you may recall things we had that were called pointers. You can think of these pointers as being sort of iterators. Iterators know how to get their next value with the next method, the dunder next method, or the simplified version of it, just calling next, which calls the dunder next method in the background. If I were to do print next nums, I will get an error message right here, because if you take a look at the directory, there is nothing that says double underscore next, and this is alphabetical, so I can see that it isn't there. So I will get an error message here. So take a look. And it says, in fact, that list object is not an iterator. Let's go ahead and convert this list object so it becomes an iterator. So here's my nums 1, 2, 3. I'm going to create an iterator nums variable, and I'm going to say nums dot double underscore iter double underscore. So call the dunder method on that, and then print inums and print the dir of that. So I see that this became a list iterator, the inums, and I can see that in here I do have the next method now, the dunder special dunder next method, as you can see. I have the iter method as well, but now I have next. So now that I have next, I can go through it one by one if I want to. Certainly I can call the iter method. Let's do that, in fact. If I do this iter method as opposed to doing it this way, I can do it this way. So this calls the double underscore iter method in the background. But what I like to do now is to use the next method. I can certainly do it this way, and I get the number 1. So it shows you the next one. It can only go forward. So if I were to do print next inums here, it's going to print the next 2. Now for this one, I'm going to make a change. I'm going to say inums dot double underscore next double underscore. So you see that the next that we use here really is calling this in the background. But let's take a look at this. And there is 2 and 3. If I were to try to do this again, because I've already gone through the 3 elements that were in that iterable, I will get an error message. So here it is. I'm getting stop iteration. This is the error that was raised, that basically I'm out of bound at this point. Let's go ahead and make our own iterator here. So this is going to be a class that I'm creating called myRange, which is going to behave like the built-in range function that we use for loops, if you recall from previous lessons. So class myRange, and we're going to have our init constructor, which has to get self. Have a start and end parameters that I'm handing. I'm going to have a self.value equals start and self.end equals end. I wish I'd call this start, but it's okay. Now I'm going to define the iter and the next methods myself. So I have the double underscore iter method that's built into Python, and I'm going to basically override its definition. This is going to simply return the object itself. So this is returning this object, which means that everything in that object will be included, including the double underscore next method, which we're defining down here. For the next method, I'm going to do a conditional. I'm going to say if self.value, that is the start value, is greater than or equal to self.end, and I can't say greater than to be inclusive. If that is the case, I'm going to raise the stop iteration error. Current is equal to self.value, and self.value gets incremented every time this is called, and then we're going to return the current value. Well, let's take a look at this. Let me first execute it. And I'm going to have nums equals my range 1 to 10. And for num in nums, print num. We can do that because we have the iter, the special iter method. So we can do a loop. We can treat it like an iterable. But we can also do this as an iterator. So if I do the same thing, calling my range, but instead say print, next nums, it prints 1. If I do it again, it prints 2, and it's going to keep moving forward, 3, 4, 5, 6, etc. Keep in mind that the generators yield a value instead of returning a result. Generators are also iterators. Now, I have a video coming up on what generators are right now. Don't worry about it. Just remember that the generator yields a value. And so generators are also iterators based on what we see right here. I want to create a generator function, even though we haven't really discussed generators here. So I'm going to create a function, my range. Start and the current is the start value, while the current is less than the ending value. Yield current basically returns that last value. And then I'm going to add 1 to the existing current. So if I do this, if I execute this, and let me insert a cell above this first and foremost, and I'm going to print type of my range right here, and you can see it says it is a function as expected. Over here I'm going to call my range. Now this is different than my range that I created up here, but that was a class, which is why I'm using uppercases, a camel notation. This one is just a function. So I'm going to do my range 1 to 10 and print next num. This was a generator function, so this is also an iterator. So it prints that. And if I were to do this again, if I print another next num, let me go ahead and insert a cell below this and then say print next num. This is going to give us 2 nums. And if I were to keep doing this, I get all the rest of them. I could also say for I in nums, print I. Because this is a generator function and it is an iterator, I've already gone through 2 of them. When I do this for loop, I should get 3 through the rest of them. And you can see I get 3 through 9 because I've already gone through 2 of them. So iterators are very useful for writing memory efficient programs. I put an instance right here. Suppose you want to write a password cracker with a list of passwords, possibly billions of passwords in a file, in a rainbow table, where you have the hashes, the corresponding hashes. With an iterator, and as we will see a little bit later in another video with a generator, we can be using these passwords one at a time instead of reading the entire thing into memory, which obviously take an enormous amount of memory. We can just go through these one at a time and use them as necessary, which is much more efficient. So they're very useful for writing memory efficient programs. That's it for this video. I hope you enjoyed it. If you love these videos, please share with loved ones and friends. And as always, thank you for being a great audience. I'll see you in the next video.